Hello and welcome to this Dr. Frost Maths key skill video on identifying regions in 2D indicated by free inequalities. Now in the previous video we saw the steps for taking inequalities like this and working out the region on the xy plane, the coordinate grid that we could be in. And these steps were as such. We first draw the lines as if they were equations, so I'll explain what I mean by that in a second. The second step is to work out what side of each line we're on. And the final step is to combine those restrictions together. So let's do the first step. We draw the lines as if they were equations. So we ignore that greater or equal to symbol and just imagine it's equations, so x equals minus 1. So how do you draw x equals minus 1? Well, that's a line, that's a vertical line that cuts the x-axis at minus 1, cuts the x-axis at minus 1, so it's going to be a vertical line like that. And by the way, if x is greater or equal to, if you've got a greater or equal to symbol, you have a solid line. And the solid line sort of basically says x could be equal to minus 1. So the solid line implies you can actually be on that line. And let's think about the second step, work out what side of each line we're on. Now, x can be minus 1 or greater, x is greater or equal to minus 1. So if the x value is greater or equal to minus 1, it's in this direction. So I'm going to put a little right arrow to indicate it could be that value or more. Now what about the next one? We're going to imagine this as an equation, so sketch this as y equals 1. Now y equals 1 is going to be a horizontal line that cuts the y-axis at 1. So if it cuts the y-axis at 1, it's going to be like a line like this. And again, because it's greater or equal to, it means we have a solid line, not a dotted line. And the second step, work out what side of each line we're on. Now the y value can be greater or equal to 1. So if the y value was greater than 1, it's going to be above the line. So we're going to put a little up arrow to indicate that we can be on this line or anywhere above it. If, for example, you're here, the y value is greater than 1. If you're here, the y value is greater than 1. If you're here, the y value is greater than 1. And so that would satisfy this inequality. The final one is more complicated. We've got y is less than 4 minus x. If we imagine that's equation, y is equal to 4 minus x. Now, we could just try a couple of different values of x and see what the y is and plot those points. You only need 2 points to sketch a straight line. Now, if x was equal to 0, 4 minus 0 would be 4. So when x is 0, y is 4. So 0, 4 would be here. And let's say if x was 4. If x was 4, 4 minus 4 is equal to 0. So when x is 4, y is 0. When x is 4, y is 0, we get this point, and we're going to have a line between those 2 points. Notice, by the way, that y is less than, but not including 4 minus x. And if it's strictly less than and not less than or equal to, you've actually got to do a dotted line. So I'm going to do a dotted line between these 2 points here, like that. And then the second step, work out what side of each line we're on. Now there's 2 ways of doing this. We could just try a point and see if we're on the right side of the line or not. So let's just take a point either side of this dotted line. Let's say, I don't know, 2, 0. Are we on the right side of the line or not? So if I write that point, 2, 0, the x value is 2, the y value is 0, does it satisfy this inequality? So if I sub in the values, the y value is 0, is less than 4 minus the x value is 2. And is this true? Well, 4 minus 2 is 2. Is 0 less than 2? Well, yes it is. So it means that point we chose must be on the correct side of this line. So it means we're on this side of the line. So I'm going to put an arrow like this. Now there is a little kind of trick way to do this, and you may like this. Now the way I do it is to see whether y is on the smaller or the larger side of the inequality. Now y is on the smaller side of the inequality because y is less than this thing. Y is the smaller value. And if y is a smaller value, you're under the line. If y is the bigger value, so y is greater than something, then you're above that line. That's the kind of quick way to do this. And now the final thing is to combine these 3 restrictions together. So we're saying we're going to be right of this line, we're going to be above this line, and we're going to be below this line. Can you see that this forms this region of points here? Because that region is right of this line, it's above of this line, and it's below this line, and you get this region here. And that is the final answer. So that means that any point in this region, so for example, this point here, which is 1, 2, the point 1, 2 is going to satisfy all three of these inequalities. If I just rub that out, let's work this out. If x is 1 and y is 2, is the x value 1, is 1 greater or equal to minus 1? Yes, it is. Let's look at the y value. Is the y value of 2 greater or equal to 1? Yes, it is. And finally, is the y value less than 4 minus the x value? Well, the y value of 2 is 2 less than 4 minus 1, because the x value is 1. Well, 2 is less than 3. That is true. So we know this point satisfies all three inequalities, and that's right because it's in this region.